Can you stop?
Okay, so next topic is all of you have signed. तुमने किया ये so what we are going to discuss now is whose bag is this? So the force experience where current carries wire when it is placed in a magnetic field. So this is given by what is called as Fleming's left hand rule. It is given by the direction of it is given by Fleming's left hand rule. Okay. So magnetic field around straight current carrying wire was given by right hand thumb rule. And now we are going to discuss what is called as Fleming's left hand rule. Okay. So stretch the thumb, the index finger, and the middle finger of your left hand. Right? Each perpendicular to each other. So what is Fleming's left hand rule? Okay. So you have the thumb, right? Thumb. This is index finger. It points in the direction of external magnetic field, right? External magnetic field. The magnetic field is always represented as B. Okay. It is the direction of the magnetic field in which the current carrying wire is kept. So it is external magnetic field. Okay. Then this is the direction of, so middle finger represents it is along direction, current direction. Where is this current? This current is flowing in the wire. So current direction is in the wire and magnetic field is where this wire is kept. Okay. So like this is magnetic field. Let's say this is the current direction. And where is the force acting on the wire? Upward. So thumb represents the direction of force. Okay. So Fleming's left hand rule gives us the direction of the force acting. Okay. On a current carrying wire when it is placed in the magnetic field. And I gave you the reason why a current carrying wire should experience a force. Because current carrying wire itself is a magnet. Because it is generating its own magnetic field. When it is placed in some other magnetic field, some interaction will take place. Okay, due to which the current carrying wire will experience a force. So simply you can draw it like this. Right? So this is your index finger. Yes. You missed one full lecture. Index finger. Then you have middle finger. This points in the direction of current. This points in the direction of force. So you can see each of these are perpendicular to each other. Okay. There is 90-degree between all three. Is that clear? Now this only helps you. Basically, all of them are at a single point. The rule is applied at a single point in the wire. Okay. So these points are single, but you can't keep it here, right? Just to help you remember the direction. So let's take a case. Okay. Case is like this. Imagine a horseshoe magnet. Let's say this is North Pole and this is South Pole of a horseshoe magnet, right? It is placed like this. And it is kept on some foundation. And you now have a current carrying wire like this, placed here. So if this is north and this is south, what is the direction of magnetic field? Up. Direction of magnetic field is up. And let's say the current is flowing in this direction, left to right. Okay. So where will this wire experience force? This is a hanging wire. Let's say the wire is suspended and current is passed through it. Huh? Where will it come? ऊपर जाएगा. ऊपर तो field है. All these are mutually perpendicular. बाहर आएगा. It will come towards you. This is what is given in the textbook. So you have a magnet, right? Let's say there is a wire. Crossing the magnet like this. Okay. And this whole arrangement is okay. Let's say the current is right. You can have it current meter also. So this is wire AB. Okay. So what is the direction of current? This is the direction. Okay. Now is the magnet. Magnet is it is perpendicular to the board. It's gone inside. This part is behind the board. So magnet is kept like this. The wire is like this. So current is flowing from A to B. Now I apply Fleming's left-hand rule. So where is the magnetic field? Upward direction. B is in the upward direction. Where is current? This direction. Where should be the force? This should be the force. So force is outward. So wire will come towards you. Okay? Understood? So this is the diagram given in the book, I think. Okay. Right? What if I change the direction of current? Current, नहीं, magnetic field में current है ना? Where is the magnetic field? This is magnetic field, right? Up. North to south. Current is this. So will be here. Okay, magnetic field is going up. Current is in this direction. So where have you applied the law? Here. This is the direction of current. So where will be the force on the wire? This one. Is that clear? Where have you applied the Fleming's left-hand rule? At a point on the wire. At any point on the wire, the current direction is left to right. Field is upward. The force will be towards you. Is it clear how to apply the rule? What happens? Some crisis. Everybody is clear how to apply the rule? You select any point. At that point, determine the direction of all three. Field is upward, current is towards right. So where is the thumb then? Let's say, do it like this. Now align two directions. Field, current is towards right. So where is the thumb? Yes. You have to do the alignment. See, field is going up, current is here. So where is the thumb? Outside. Okay, so you have to match the direction. That's it. And this can get difficult. Okay, so do not turn it by more than 90 degrees. So if this is the direction, what is fixed here? Direction of magnetic field is fixed. Okay, so take that as the axis. Direction of magnetic field is fixed. Now where is the current? Current can go either this way or this way. Turn it only by 90 degrees. Then the thumb. Choose one as axis, then turn it like this. If the axis is like this, then it will be like this or like this. Okay, students struggle sometimes. They just turn the full body. No, you have to only turn it by 90 degrees. Okay, so it will take some practice. Otherwise, you might sprain your hand. Okay, is that rule application of the rule clear? Only twist by 90 degrees on either side. That is how you have to align. Remember it. Choose the axis. So B becomes axis of symmetry, then current will go either left or right. Okay, that's it. Force causes motion. So sometimes this force is producing motion. What is cause of motion? Force. So sometimes instead of force, it will be used as motion, more so in case of generator. So generator is opposite of this, where the rule will become Fleming's right-hand rule. Magnetic force. The force is actually in 12th standard you are going to read about this, the basis of this formula. This formula is mentioned in your book. So the force is because of current carrying wire placed in the magnetic field. L is the length of the wire inside the field. Ask, come up. This is the force acting on the wire because of magnet. Both are magnet. Wire is also magnet and the external magnetic field. देखो कभी कभी क्वेश्चन ऐसे दिया जाए. Let's say okay, let me test you. What is this? What is this? Uniform magnetic field. Okay. Now electron is falling in this. What am I doing? I am dropping a electron in this. What is the direction of force? Into the how? Very good. So direction of current is opposite. This is how they will twist the question. The direction of flow of electron is not the direction of current. And this rule, current is conventional current. All rules, whenever I am saying current, it is always positive to negative. See, what is the current direction? This I is positive to negative. Current is always conventional current. Okay. No question is expected on this formula. It is just mentioned in Selena. No numerical will come on this. Only application of left-hand rule for the different scenarios. You should only know that. Okay, they will give you different scenarios and you should know how to apply Fleming's left-hand rule. Have I answered your question? What is the force? It's this force, which is acting on the current carrying wire when it is placed in some external magnetic field. So what is the external magnetic field? It is due to this magnet. Then this current carrying wire also is behaving as a magnet. So magnet, this magnet near some other magnet will have some force acting on. And the direction of that force is given by Fleming's left-hand rule. Okay, is that clear? Okay, so Fleming's left-hand rule gives what? क्या बताता है Fleming's left-hand rule? Question comes like this: state and explain Fleming's left-hand rule. What will you answer? Have you heard the question? State and explain Fleming's left-hand rule. Yes. You raised your hand. No? You were testing rule. State and explain Fleming's left-hand rule.
Fleming's left-hand rule helps us to find the direction of force.
First, state the rule. How will you state Fleming's left-hand rule? When the index finger, listen, how to state Fleming's left-hand rule? When the index finger, the middle finger, and the thumb of the left hand are stretched mutually perpendicular to each other, then the index finger points the direction of external magnetic field, middle finger points the direction of conventional current, and the thumb points in the direction of force acting on the current carrying wire placed in the external magnetic field. This is the rule. Okay, so I have stated and explained. Is this clear? So in this chapter, these kind of questions will be there. Everyone understood? Can I proceed to the next rule now? Okay, let's go further. So now the application, where is it applied in real life? In real life, it is applied in DC motor. How this fan is running, how any motor runs. We'll understand the application of Fleming's left-hand rule while we discuss the working of a DC motor. Okay. So let us see what is a DC motor. So first let us understand the construction of so what are the building blocks of a DC motor? So you require magnet, so this is nothing but part of a horseshoe magnet. What is it? It's a horseshoe magnet. We are only showing the part of it, broken part. Okay. Now we have placed a rectangular coil in it. The loop could be circular or rectangular. It is a loop. What is the shape of the loop? Rectangular. And it's not a loop, it's a coil. So it will have multiple turns. What you see is only one turn, but let's say it has n turns. Okay. So it's a rectangular coil. And it is mounted on a axis. Right? So this is some axis. What is the arrangement? You have a magnet in which a rectangular coil is placed. Okay, this is how it is. So the coil is like this. So coil mein, what do you have here? The coil has been turned to look like two, means it's like a split ring. What is it? Split ring. The two parts are named as S1 and S2. Okay. So now you have to pass the current in it. There should be some provision to pass the current in it. So the current will be passed through what is called as carbon brushes. So these brushes provide flexible contact. Okay. So what have we done? We have made an arrangement to pass the current. Right? So this is the diagram of DC motor. Now let us say switch on the current. So when I switch on the current will enter through S1. Current will enter the coil through S1. This is how the current will go. Right? So this is how the circuit is complete. How the current is entering? Through brush B1. And then this is how it is going through the wire. Let's name the coil as ABCD. So the name of the rectangular coil is ABCD. So current direction is ABCD. This is how the current is entering the coil. Now, what is the magnetic field direction? Everywhere the magnetic field is from north to south. So the external field direction is north to south. So now let us select these 2 points. Right? Let us select these 2 points. Now tell me at this point, what is the direction of force acting on the arm AB? So at this point, what is the field direction? Here. What is the current direction? Inside, A to B. That means it is going into the plane of the pole. What is the force direction? Downward. Okay. So everywhere, any point, take any point from A to B, the force is acting downward. Now predict the direction of force here. Again, B is in this direction. B is in this direction. Current is coming towards you. So where is the thumb? Up. So here the force is upward. Will the magnitude of force same or different? Will the magnitude of force be same or different? This is going up and this is going down. Will the magnitude of force be same or different? Why? Magnitude, I'm not saying direction. Direction is opposite. Why the magnitude of force different? Is it not uniform magnetic field? So magnetic field is B here. Same current is flowing through the wire. So B is same, current is same. So force ought to be same. So you are experiencing, let's say you have a coil. Here the force is down and here the force is up. So it will experience the couple or torque. How will it begin to rotate? It will begin to rotate like this. The moment you switch on the current, it will rotate anti-clock. Understood how it is rotating? What is making you so amused? Share it with the class. Have you understood or no? Yeah. So this is a pair of forces acting in opposite direction. Since it is a pair of force, it is called couple, and it is also known as torque. First chapter. So this coil will now experience a torque. So how? So therefore it will begin to rotate in anti-clockwise direction. For me, so this side is going up and down like this. Okay. So then you have to understand the role of B1, B2 and S1, S2. What is the role of S1, S2? So S1, S2 is nothing but it is called split ring commutator. Right? And B1, B2 are brushes. Provide. The B1, B2 are providing the electrical contact to the coil. What is the role of S1, S2? Now tell me. This was named as A, B, C, D. Okay. So in AB position, S1 was touching which brush? B1. B1 will always supply the current. And B2 is passage out. Current comes out from B2. That's how the circuit is completed. Okay? B1 supplies the current in and B2 takes the current out. So now after 180-degree rotation, what is the status? This was AB and this was CD. After 180-degree, what is it? This is DC and this is AB. After 180-degree. Now, when it was initially AB was experiencing force downward. And what was the current direction in AB? A to B. Okay. What was the current direction in CD? C to D. Now, when CD comes here, B1 is now in contact with S2 and B2 is in contact with S1. So now B1 is forcing current inside what direction? D to C. What was the earlier current direction? C to D. Now what is the current direction? D to C. Okay. And what about this? This is now B to A. So after 180-degree rotation of the coil, because of split ring, the current in the coil changes. The direction of the current in the coil changes. So what is the role of commutator? To change the direction of current in the coil so that the couple keeps acting in the same direction and coil continues to rotate in the same direction. That's why these brushes, this ring is sliding over it. It is slipping. There is no firm contact between B1 and S1. It is a spring arrangement so that it slips over it. When it rotates, it slips over it. B1 is fixed, but this coil slips over it. Okay? So it is slip ring and split ring. Slip, split ring. Okay? Understood? S1, S2 slips over B1, B2. Because if it was not so, it will break the winding. It will twist and break it. So it's a flexible contact. Is that clear? That's it. So what is the role of split ring? To change the direction of current. In the coil after half rotation. Is the working of DC motor clear? No question will be asked on working of DC. That was only for your understanding. What will be asked? How Fleming's left-hand rule is applied. So questions asked is well drawn diagram, fully labeled, okay, and how the Fleming's left-hand rule is applied, so that you give the direction clear. Okay, and the role of B1, B2, and S1, S2. Okay, they are not going to ask you to explain the working of DC motor, but there will be diagrams given. Then if they will ask some question related to Fleming's left-hand. Then there is a question: how the speed of rotation of DC motors can be. So how can we increase the speed of rotation? So this coil has number of turns. It is a coil, so it will have few number of turns. So first is by increasing the number of turns. In the coil. Okay. How the rotation will increase? By increasing the couple. And what is the force acting? Force is ILB sin. So I said the force is only acting on AB and CD. Why not BC and AD? Why not BC and AD? You see this sin theta? So for this case, theta is the angle between the length of the wire and magnetic field. Okay. So the length of the wire and magnetic field, this theta is 90 here. Okay. This is the length of the wire and magnetic field. This is 90 here. Whereas here, the length and B, here theta is 0. Both B and L are in the same direction. And here it is 180. Sin 0 and sin 180 will be 0. So there is no force on BC and AD. There is no force on BC and AD. The only force is acting on AB and CD. Okay. So if we increase the number of turns in the coil, obviously this force will become n times this. This is the force on one turn. If there are n turns, then force will be NILB sin theta. Clear? Now, second. Can you see this area? By choosing a coil of bigger dimension or increasing the area of the coil. So if you have a small size motor and a big size motor, a big size motor can be rotated at a higher speed because now the coil area will be bigger. Third, what else you can do? Third is by increasing the magnitude of current because all these factors it will depend on. Whatever increases the couple will increase the speed of rotation. So by increasing the magnitude of current. Okay, these are some of the things you can do to increase the speed of rotation. And you can also insert the soft iron core because if you insert the soft iron core, the magnetic field will increase. Okay, so by inserting soft iron core. Remember in solenoid we said when you insert the soft iron core, the magnetic field strength increases. So here it is a rectangular coil. So here also, means you can have a core and on top of it you can wrap the wire. Let's say you have a cylindrical drum and the coil is wrapped around this. So you will see it as a rectangle, but this is a core. So core is mounted, on top of it the wire is wrapped and the whole thing then becomes a, like you have increased the magnetic field. Okay. So these are some of the things you can do to increase the speed of rotation of the DC motor. So I want to take 2 minutes to think over what all we have discussed. See the text in your book. Last week very severe. तो पर्सपेक्टिव का फर्क है, डायग्राम 3D में 2 डायमेंशन में बना है। ऑयल कैसे है? कैसे रखो? ऐसे पकड़ो, इसको ऐसे पकड़ो, उसको तो ऐसे पकड़ो। Everybody look here. Okay, this is the coil. This is the arrangement. Are you able to see? Look here. The question you asked. This is North Pole. This is South Pole, and the coil is kept like this. Okay. A, B, C, D. सबको दिख रहा है? क्या है? Coil is placed like this between the two poles. Field का direction क्या है? ऐसे. और coil में current कैसे आ रहा है? B से आके S1 से ऐसे आ रहा है, ऐसे. तो करंट इधर हो गया, B ऐसे हो, कोई भी एक पॉइंट हो, यहाँ पे करंट कैसे ऐसे, B ऐसे है. अब लगाओ लिमिट्स लेफ्ट हैंड रूल, तुम लगाओ, लेफ्ट हैंड फ्री है ना हमारा. Where is current? This is B. Current is this. करंट कैसे है? करंट ऐसे जाना चाहिए ना. पहले B अलाइन करो, B अलाइन करो. B कैसे है? ऐसे. करंट कैसे? ऐसे. कौन कैसे आएगा? नीचे. थोड़ा प्रैक्टिस करिए. ठीक है. तो बुक में जो डायग्राम दिया है, पूरा चैप्टर पहले राइट हैंड कंपोनेंट, उसके बाद लूप में कैसा राइट ये वाला कैसे बनता है? यहाँ से जो तुम्हारे घर तक लाया जाता है कोई ये जो है आईटी का एक मत मीटर हम सभी है ये डिस्ट्रीब्यूशन मोड है. सेटिंग में एक बोला आजकल डिस्ट्रीब्यूट कैसे होगा? मीटर रूम तक कैसे आ हर फ्लैट में 3 थे। उसके बाद ये कैसे कनेक्ट होता है लाइव कैसे इसमें हम एक्स्ट्रा दिया हुआ है वो सब एक बार पढ़ अगर प्रॉपर टेम्परेचर So anybody has a question के लिए? हाँ. I'm not able to hear. Background. Carbon versus.
Can we say
Can we say the
that is increases the surface area?
carbon versus?
Yeah, but when it with
This is just a contract. Let us say that's a receiving diagram. Now it is like and then there is no after 90-degree. When this part comes here, there is no connection. Then by inertia it turns. When the coil is like this, the force is up and down, no torque. Here there is maximum torque. Now when the coil becomes like this, the force is up and down. So no torque in this position. So due to inertia, it goes ahead. And then this comes in touch with it. Okay? That's why there is split, no? Change of direction kaise hoga nahi to? That's why it is split. Okay? Okay, I forgot to mention there are two types of electromagnets possible. If DC motor is not then the self-increase. Please say that again. If DC motor explanation. How to increase the speed? Yes. There are questions based on this. So if you know this, you'll be able to answer. So the electromagnets come in two shapes. I shape and U shape. So what is I shape? I shape is this. The solenoid, right? This is I shaped because it resembles English letter I. Right? What is the pole here? What is U shape? So when you turn it, then it becomes U shape, but you have to be careful about the winding. Now see how will you wind it? So let us say that the current is in this direction. It will develop which pole? What pole it will develop? कौन सा pole होगा ये? South. ये clockwise. यहाँ पे नॉर्थ नहीं है, हमको कैसा चाहिए? एंटी क्लॉकवाइज. ये ऊपर से जा रहा है, यहाँ से नीचे से. So you have to be careful about the windings. है ना? वाइंडिंग कहाँ पे चेंज हो रहा है? एक में क्लॉकवाइज मिलेगा तो साउथ बनेगा और फिर ये इसको हम नीचे से ऐसे टर्न करेंगे. ऑपोजिट टर्न होना चाहिए दोनों में. ठीक है, तो यहाँ से कैसा रहा है? एंटी क्लॉक. ठीक है, बस ये दो टाइप ऑफ आई एंड यू शेप इलेक्ट्रोमैग्नेट्स है. ठीक है, तो जो डीसी मोटर है वो इसके बीच में बनेगा, लेकिन यहाँ पे कॉइल रहेगा. तो अब ये नॉर्थ साउथ हो गया. ठीक है, तो इस केस में कैसे चलेगा हमारा कॉइल? क्लॉकवाइज चलेगा. पहले केस में कैसे चल रहा था? एंटी क्लॉकवाइज. ठीक है, इज दैट क्लियर? सब लोग सुन रहे हो या खाली गप्पे मार रहे हो? क्या हो गया तुम? समझ आ रहा है? अच्छा, वर्किंग ऑफ इलेक्ट्रिक बेल ये देखना है. किया था. ठीक है, एनीबॉडी वांट्स वर्किंग ऑफ इलेक्ट्रिक बेल? व्हाट? इसमें कोई क्वेश्चन एक्सपेक्टेड नहीं बिकॉज़ इट वाज इन राइट. सेम थिंग. Okay. Stop here only, right? So whatever I have taught, you just go through it. If anybody has any doubt, you can ask some more doubts. Try to attempt questions at the back of the book. Let's see what are the questions. Two application type questions. Page number 81. Page 81 application type questions. The question was going to be okay. What will happen when the current in the wire is decreasing? 81. Application type questions. Question 1. क्या होगा first part? What is the answer to the first part? Everybody has volume. So you have come to watch a movie. Textbook में है क्या application type question? Every class I say that bring volume. Somebody read the question. पढ़ो box question पढ़ो. ठीक है, we'll do the question in the next one.